What if you looked up into the night sky and the moon was simply gone? Imagine it. The familiar, comforting silvery orb that guided sailors, inspired poets, and illuminated countless nights suddenly vanished. It's not behind the clouds. It's not a new moon. It has disappeared from existence, instantly and without a trace. What would happen next? Would our planet continue its journey through the cosmos undisturbed, or would this sudden absence trigger a cascade of catastrophic events that would unravel life as we know it? These are not questions of fantasy. They are profound scientific inquiries about our existence and the solar system's balance. The moon is not just a pretty light in our sky. It is a massive celestial body, a constant companion tethered to Earth by the invisible, powerful force of gravity. Its presence shapes our world in ways we often take for granted, from the rhythm of the oceans to the stability of our seasons. The repercussions would not wait centuries or millennia. They would begin immediately, sending shockwaves through every system, from the deep oceans to the atmosphere above, fundamentally changing the world we live in. Today, we are not here to speculate based on fiction or fear. We are here to explore what science, with its rigorous models and evidence-based predictions, says would really happen if our moon were to disappear. We will embark on a journey to paint a clear, confident, and startling picture of a world unmoored. Prepare yourself. The answer is more dramatic than you might imagine. To truly grasp what we would lose, we must first understand what we have. The moon is a colossal celestial body, bound to Earth by gravity. This partnership, detailed by Isaac Newton, is an equal and opposite force, the root of its influence. This pull is not uniform. This difference creates tidal forces, which stretch and deform the planet, pulling the oceans into two bulges. As Earth rotates beneath these bulges, we get the rise and fall of the tides. Beyond tides, the moon performs an even more critical function. It acts as our planet's gyroscope, stabilizing Earth's axial tilt of 23.5 degrees, the very reason we have seasons. Other planets, like Mars, experience wild swings in their axial tilt, causing dramatic and chaotic climate shifts. Earth is spared this fate. The moon's pull acts like a steadying hand, anchoring our obliquity and ensuring our world remains temperate and hospitable. If science-based answers like this excite you, subscribe to Doubts Undertaker, like this video, and share it with someone curious about space. In an instant, the moon is gone. The primary force driving the tides would vanish. Tides would shrink to about 30% of their height. The intertidal zone would be permanently exposed or submerged. This would trigger a mass extinction event along every coastline on Earth. Critical nurseries for fish and feeding grounds for migratory birds would collapse, sending shock waves up the food chain. The friction from the moon's tides acts as a brake. Remove that brake, and the Earth would begin to spin faster. Our 24-hour day would be a thing of the past. Scientists estimate a day would eventually settle between 6 and 12 hours, throwing the biological clocks of every living thing into disarray. Then, there is the darkness. Without the moon, nights would be profoundly dark. Outside cities, darkness would be absolute and impenetrable. Predators that rely on moonlight would struggle. Prey that use darkness to hide would gain an advantage. The entire nocturnal food web would be upended. The truly world-altering consequences would unfold over millennia. Without the moon's anchoring influence, our planet's axis would begin to wobble chaotically. Models predict Earth's tilt could vary erratically between 0 and 85 degrees. Our 4 seasons would be replaced by a chaotic climatic pendulum. Imagine an Earth tilted to 85 degrees. For a quarter of the year, the North Pole points straight at the sun, experiencing 24-hour daylight and unimaginable heat. This would trigger climatic feedback loops, plunging the planet into alternating periods of extreme ice ages and scorching hothouses. The melting of ice sheets would cause a catastrophic rise in sea levels, submerging every coastal city. Evolution would favor only the most resilient generalists. Humanity would be forced into a nomadic existence, and our very concept of time, the month, would lose its astronomical anchor. If this episode changed how you see the moon above you, comment your thoughts, share this video, and subscribe to Doubts Undertaker. After exploring this cascade of consequences, it is time to ground ourselves in a fundamental truth. The moon cannot simply disappear. The law of conservation of mass and energy dictates that its mass would have to convert to energy, an incomprehensible blast that would instantly vaporize Earth. So why explore it? The answer lies in the power of the thought experiment. By imagining the impossible, we can illuminate what is real and true. This thought experiment helps refine our search for life on exoplanets, guiding us towards systems with the long-term stability necessary for life to evolve. This journey should change how you see the moon. It is not just a rock. You are seeing the anchor that holds our seasons in place. You are seeing the engine that drives the ocean's breath, the guardian that ensures our world remains a place of relative calm in a chaotic cosmos. The evidence is overwhelming, and the conclusion is clear. The moon isn't just a light in the sky, it's a stabilizer of life. If this explanation challenged your understanding of the universe, comment below, share this video, and subscribe to Doubts Undertaker.